Assalamualaikum warahmatullahi wabarakatuh, and a very good day to Dr. Muhammad Azri and fellow friends. Today, we're going to present about topic 7, construction machineries and equipment, which is excavator. Before that, we are from group 28 and 29 that consists of 4 members. Nurul Anis Nazira binti Mat Khalib, Nurul Aina binti Fadil Izam, Afifah Nabila binti Muhammad Fauzi, and Anis Anisa binti Azmi. Hydraulic excavator. Hydraulic excavator is a heavy machine that has various sizes, a hydraulic arm with a blade at the tip, designed to move on wheels or chains, and also has the ability to rotate 360 degrees on its own axis. There are many types of excavators, including crawler, wheeled, suction, and dragline excavator. The crawler or standard excavator is used for mining, landscape grading, and trench digging. It is good for uneven terrain, however, it's slower than wheel excavator. It is named as crawler because it runs on 2 rotating tracks instead of wheels. The wheel excavator is used for jobs on flat or hard surfaces. It is fast and easy to move on concrete, but it won't work well in muddy or hilly terrain. The wheel excavator is like the standard excavator. It has wheels instead of tracks. The wheel excavator is best used on asphalt or concrete because it has less traction than the standard. This is suction or vacuum excavator. It is used for fragile digging jobs, debris cleanup, and underground projects. The advantages is it can reduce the chance of damaging the surrounding area or underground utilities. The disadvantages is it not applicable for large-scale projects because of its size. And of course, it functions as a high-pressure vacuum. The last one is dragline excavator. It is used for deep pile driving, harbour construction, surface mining, and others. The dragline excavator have a digging depth of 65 meters or more. It is only usable for specific jobs. It is larger than the standard and uses a hoist rope system and a dragline to raise and lower the bucket and drag it towards the driver. This excavator also ideal for excavating underwater. The picture shows the excavator attachments and parts. They are numbered and named accordingly as shown in the picture. There are many shapes and sizes of excavator. They are different depending on their functions. The advantages of hydraulic control are faster cycle times, precise control of attachments, high overall efficiency, smoothness and ease of operation, positive control of attachments. If an excavator is considered as independent unit, a one-link system, its production rate can be estimated using these steps. The picture shows the basic production formula in the case of excavator.
Excavator accident. During the period 1992 to 2000, National Institute for Occupational Safety and Health identified a few common causes of injury from an excavator accident. The first causes is being struck by the moving machine, swinging booms, or other machine components. Number 2, being struck by quick disconnect excavator bucket that unexpectedly detached from stick. Number 3, rollovers. Number 4, machines sliding into trenches after cave-in. And number 5 is electrocutions. To prevent an excavator accident from happening, the worker should always follow safe practices. The first safe practice is operators keep machines attachments at a safe distance from workers at all times. Number 2, workers are trained regarding safe practices when working in close proximity to heavy equipment. And number 3, supervisors consider alternative working methods that eliminate the need to place workers in close proximity to heavy equipment. Next is the example of excavator accident due to carelessness. The thing I want to highlight from this video is safety activities must be coordinated on multiple employer work site and don't start the job until the proper equipment and procedure are in place.
Before you start a job, make sure a hazard assessment and a job plan have been done. That didn't happen at this well site. Instead, the workers improvised. Things went terribly wrong. A truck driver arrived with a load of concrete barriers. He'd been told that there would be a picker truck for offloading, but there wasn't one. Instead, just before the truck arrived, an excavator operator on the site was directed by his supervisor to offload using this excavator. With no proper lifting attachment on site, the two workers improvised with what was on hand. The truck driver had some tie-down chains, so he rigged them above the excavator bucket and around the two grooves beneath the barrier. When the excavator lifted the barrier, one chain slipped out of its groove. The truck driver waved to the excavator operator to stop and to lower the load so he could reposition the chains. The operator couldn't hear what the driver was saying, so with the load suspended, he engaged the safety lockout lever. This disabled the operating controls, preventing the excavator and boom from moving. He then exited his cab and talked to the driver. As the operator climbed back into the excavator, his pant leg snagged the safety lockout lever, releasing it. This enabled the controls. His left pocket then snagged a joystick. The excavator's boom suddenly swung. The barrier glanced off the driver's chest, dipped down, and then struck his lower leg, knocking him off the flat deck. The barrier then slipped from the chains and crashed onto the flat deck. This accident didn't have to happen. Safety activities must be coordinated on multiple employer work sites.
Now we move to hose. The other names of hose are backhoe or back shovel. Function of hose is used primarily to excavate below the natural surface of the ground on which the machine rests. The other information about hose that we must know firstly is hose is superior to red lines for close range work and loading into hull units. Secondly, hose can adapt at excavating trenches and pits for basements. There are two examples of hose. Firstly is crawler mounted hydraulic hoe. This hoe has crawlers that are often used in mining jobs and heavy-duty construction jobs, for example used at highway, sewer, and pipeline and railroad. Then, the chill wheel system allows them to slide down and scale hills with less risk, making them suitable for grading hilly areas and landscaping uneven terrain. While slower than other excavators, crawlers provide overall greater balance, flexibility, and stability. Then the chain wheel system allows them to slide down and scale hills with less risk, making them suitable for grading hilly areas and landscaping uneven terrain. While slower than other excavators, crawlers provide overall greater balance, flexibility, and stability. Secondly, wheel-mounted hydraulic hoe. This hoe available with buckets up to 1.5 cubic yard and maximum digging depth for the larger machine is about 25 feet. Besides, the large machine can handle 10,000 pound loads at a 20-foot radius. Next, we move to basic part and operation of hoe. There are three basic parts of hoe that we must know. Firstly is boom. Secondly, stick, and thirdly is bucket. In operation of hoe, the stick and bucket cylinders provide penetration force into the dark material. When the stick cylinder rotates perpendicular to the stick, the maximum crowd force is generated. Because of the geometry of the boom, stick and bucket, plus the fact that the hydraulic cylinder applies the most power drawing the stick in and curling the buckets towards the bottom of the arc, the potential to break material away is at its greatest. D is operating range of a hydraulic hoe. The operation starts with dumping height that involve boom, stick and bucket. When the process achieved at part B, digging reach, the hoe is at stable condition and ready to dig the soil. Then it will move to the part C, maximum digging reach. At this part, the bucket is digging the soil. There are two figures that show the detailed digging control system for hydraulic excavator. Now look at the figure 1. The hoe is at the digging position, which is ready to dig the soil. Then it moves to the level digging, the bucket digging the soil. After that, the hoe moving to the letting out position. Lastly, bucket letting out the soil. While the operation in figure 2 is same with figure 1, for your information, the other name of stick is arm. To make sure we understand more about the operation, now we will play a video.
A hole, I'm going to extend that out. Again, we start all the way out, so I've got the stick extended. You bring it down towards the ground, stopping a few feet. This is where you want to make sure your teeth are relatively out a little bit, so right about there. Put it down in the ground. Once it's in, I'm just going to go right hand to the left, curl that bucket all the way in. Raise it up, and then I can spin left or right to dump right in there. That's fully extended.
Table 11.2 show the dimensions, loading clearance and lifting capacity of hydraulic crawlers hose that commonly we use in the construction.
Bucket rating for hydraulic hose. PCSA and SAE using a 1-to-1 angle of repose for evaluating head capacity. It present in the figure 9.11 in the next slide. Next, bucket selected based on the properties of materials. By matching bucket width and bucket tip radius to the resistance of materials, full advantage can be taken of hose potential. Next, wide buckets are used to excavate material easily. Fill factors for excavator buckets adjust rated bucket heap capacity based on type of material being handled. Present in table 9.4 in the next slide. Next, this is the table of fill factor for hydraulic hoe bucket, and the next one is a figure of hydraulic hoe bucket capacity rating dimension. Next, this is a few example of excavator buckets. Buckets number 1 is digging bucket. Most of excavator models use digging bucket. It have a different size in order to meet the demands of the surface. It has a short blunt teeth used for soft soil. Bucket number 2 is rock bucket. Rock bucket have more powerful punch than its counterpart and used for a hardened surface. It has a specific design and can be used for special application only. And it have a sharper teeth, and the bucket are reinforced with added material. Bucket number 3 is grading bucket. It used for leveling and smoothing out aggregates and soil. The bucket has a sharp edge with no teeth. The bucket can be wider without increasing the weight because the design have a lower capacity. Selecting a hoe. There are a few factors should be considered in selecting a hoe. Factor number 1 is maximum excavation depth required. Number 2 is maximum dumping height required. Number 3 is maximum working radius required for digging and dumping. And the last one is hoisting capability required. Here is the guideline for rated hoist load. Number 1, rated hoist load shall not exceed 75% of the tipping load. Number 2, rated hoist load shall not exceed 87% of the excavator hydraulic capacity. And number 3 is rated hoist load shall not exceed the machine's structural capabilities.
Hoe production. There are 4 elements in the production cycle of a hoe. First, load bucket. Second, swing with load. Third, dump load. Fourth, return swing. It should be noted that a hoe does not travel during the digging and loading cycle. Travel is limited to moving away from the phase of excavation as the work progresses. This video shows a crawler-mounted hydraulic hoe lifting a capacity. The optimum depth of cut for a hoe will depend on the type of material being excavated and bucket size and type. As a rule, the optimum depth of cut for a hoe is in range of 30% to 60% of the machine's maximum digging depth. This is the basic production formula for a hoe used as an excavator. Calculation step by step. Step 1. Determine the size of bucket. Step 2. Refer table of fill factors for hydraulic hoe buckets to determine the bucket fill factor. Step 3. Refer table of excavation cycle times to determine typical cycle element times. Step 4. Efficiency factor. Step 5. Refer table of representative properties of earth and rock to determine the class of material. Step 6. Probable production. Hoe cycle times are usually of greater duration than those of other excavating machines. Part of the reason for this increase in cycle time is that after making the cut, the hoe bucket must be raised above the ground level to load a hoe unit or to get above a spoil pile. If the trucks can be spotted on the floor of the pit, the bucket will be above the truck when the cut is completed. Then it will not be necessary to raise the bucket any higher before swinging and dumping the load. Every movement of the bucket equals increased cycle time.